our third Anachem Crash Course video. So actually class, naunang practice test, no practice test 1 and 2, kung medyo challenging sila for you, itong practice test 3, for sure, mas madali ito. Okay, pero class take note na equal naman ang treatment natin sa mga chapters. So here for Anachem 3, we have the following topics: analytical techniques. So we will have an overview of the analytical techniques from classical to instrumental, followed by qualitative analysis of cations, and then gravimetric methods. So ito class ang start ng chapter natin kung saan nag-discuss tayo ng techniques. Okay, so each of our practice tests will be devoted na class sa mga analytical techniques. And starting ngayon, we have the first one, which is gravimetry. Okay, so class, ito ang overview ng mga analytical techniques in your manual. So please pakibasa ha. So gravimetric and volumetric sila yung una because they are the classical. They are the classical techniques. So here, later, meron tayong gravi, and then in Anachem 4, volumetric methods ang topic natin. Then here class, meron tayong konting portion on thermal kasi may relationship ang thermal and gravi in the technique or in the method called thermogravimetric analysis or TGA. So meron tayong ganyan mamaya. Radiochemical, this will be discussed after electrochemical methods, and then chromatographic and spectroscopic. So class, thermal up to spectro, ito na ang instrumental topics natin. Okay, so we will give importance to both classical and instrumental techniques. Kaya wag sabihin na ma'am, instrumental lang daw yung mahirap. Class, may classical pa rin. And kahit na old yung mga methods ito, no, old but gold naman sila. Ibig sabihin, they are still useful. They are still being used in laboratories. Okay? So let's have an overview, guys. Hindi na kung kaya ninyong sagutan yung mga pictures na to. So here you have weighing the sample, dissolving, precipitation. O next, syempre nag-precipitate na. Isa-separate pa yun. Filtration, drying, and weighing. O kaya na bang sagutan? Ito class ay gravimetric. Okay? Specifically, precipitation. Itong type ng gravi technique na ito. Next, okay, let's watch the video. So mag-add tayo ng indicator sa sample. Siyempre, acidic yan, clear and colorless. And then let's get our burette stand with burette. Ayan. O, diba? So nagtatitrate siya, ma'am, to the pink endpoint. No, volumetric itong technique class na to, obviously. Alright? So you're comparing your amount of titrate with the amount of analyte in the sample. Next, mga sophisticated na instruments. So class, ito naman ang para sa thermal. Okay, mga thermal methods na mga to. Anything to do with temperature. So we have TGA, DSC, DTA. So class, reading homework nyo ito, ha? Next, for sure, naalala to. Gas chrom yan, guys. GC. So this is chromatographic. Alright? Next, ito naman class, interaction ng light with matter. Meron pa tayong flame atomizer here. O alam na, mag-AA kasi, no? Spectroscopic. Alright? So class, ng ating short overview ng mga aaralin natin ng mga analytical techniques. Alright? So now we move on to o yung tawag namin dyan, qualitative analysis of cations. Guys, may mga students na nagsabi sa akin na, ma'am, parang may kami experiment. Diba? So there were students telling me na naalala nila to. In fact, ako din guys, when I was a student and when I became a lab instructor, meron din kami ganitong activity. In fact, parang practical exam pa nga namin where we have unknowns. We have to determine 5 of our unknowns and kailangan ma-separate namin sila. At pag-separate na, kailangan ma-confirm kung anong specific na alin ang present. Okay? And remember, we also use HCl as the first reagent. Kapag binakita kang nag-precipitate, pagkalagay mo ng HCl, boom, isa dito or one or more of the following group 1 ions meron. Ma'am, yung group 1 ba na yan? Hindi ba yung group 1 sa periodic table? Siyempre hindi. Ito ay group according sa kanilang properties, solubility, acid-base, complexation, redox. Okay, so mainly solubility. Kasi nga mag-add din ng reagent, may nag-precipitate. Ayan. So alam naman yun yung pumasa, diba? Lead, mercury, silver. Alright? So ito class, ang first reagent ay add ninyo, HCl. Remember solubility rules, chlorides are soluble except pumasa, lead, mercury, and silver. So one of these ions, one or more of these ions could be present in your sample. And then tuloy-tuloy lang until ma-separate mo at makita mo anong mga ions ang present in your sample. So a more detailed procedure is here. So pag ginawa nito class sa lab, dapat meron kayong schematic diagram kung ano na, saan pupunta yung procedure nyo. So kapag may nakita ka na nag-precipitate, separate, filter, and then move on to your filtrate, add the next reagent until you know all of your ions, all of your unknowns. Alright? So pwede yung group 1, 2, 3, 4, 5, minsan naman A, B, C, D. Okay, depende kung anong source ninyo. Sa manual guys natin, ay adopted naman a Roman numbering system, 1, 2, 3, 4, 5, 6. And then ito yung mga reagent. Take note, class, lumang method to ha. Sa board exam kasi they still use H2S, hydrogen sulfide. And here are their characteristic precipitates and notable. Ibig sabihin class, they're hard to miss kasi notable ang pag-confirm sa kanila. Katulad na ng lead, ng mercury 1, copper, iron 3, aluminum, nickel, cobalt, and syempre makakapigil niyo class ng flame test. Kung meron pa hindi ma-identify, flame test siguro na. Okay? So class, ayan, according ito sa mga properties nila, mainly solubility. If you notice towards the bottom, especially itong group 6, ito na yung mga soluble ions natin. So syempre class, hindi sila agad-agad magpapakita kasi nga hindi naman sila insoluble, hindi sila nagpa-form ng precipitate. So those that form precipitates, as you can see, sila yung nasa top ng groups natin. Okay? So let me show you guys ang mga notable. Okay? Ang mga notable na ions. So lead, copper, iron 3, aluminum, and nickel. Kung medyo lumalabas sa board exam po, lumalabas to guys sa board exam. Kaya very objective type lang yung mga tanong. So dapat correct kayo. Kailangan tamaan nyo ito. Okay? So let's see guys, tingnan nyo. Kung meron kayong group 1, again, you will be adding HCl. At pag may nag-precipitate, boom, alam mo na, you have 1 or more of the group 1 ions. And if you want to test if it's containing ng lead, add ka ng iodide. Mark to ha ng picture to ha. Add kayo ng iodide because the result PbI2 solid or precipitate is color yellow. Next, na hard to miss. Ito naalala ko, meron ako nito eh. Meron akong ganitong ions unknown ko. Kaya nga, imposible nga hindi mo siya ma-identify ang nickel. Upon adding DNG, ay base ang ligand, dimethyl glyoxide to a solution containing nickel, boom! May makikita kayo class na cherry red precipitate. Take note ha, ganitong kulay, cherry red precipitate. So kahit complexation reaction, nag-form siya ng solid yes. So later you will know class in our Anachem 4 that complexes, some of them are used to precipitate out metal ions. Alright? So ayan, ang mga very notable. O kunwari na or recall from basic in or iba-iba class ng ions na present. For example, sa red, possible ions are calcium, strontium. Sa yellow naman ay posibleng sodium. Sa green naman, barium. So class, kindly refer to your lesson on flame tests. Ito, tinukuha na class ng Chloe ng basic in-org ninyo. In-org 1, okay, electronic structure of the atom. Alright, so ayun guys, diba, ang bilis lang natin sa first parts ng lesson natin. So overview ng analytical techniques and review ng qualitative analysis of ions. Ang highlight talaga ng chapter class na ito or ng Anachem 3 natin ay gravimetry. So we have gravimetric methods. We will go over the types and then zoom in tayo sa specific method, precipitation, then a little background on the instrumentation of PGA and boom, calculations na guys agad tayo. Alright, so gravimetric methods are quantitative techniques that determine the quantity of an analyte by measuring the mass of a pure compound chemically related to it. Take note ha, kailangan related. Kaya nga, may stoichiometry na involved here. Everyone, ang ipo-focus natin guys dito, precipitation, gravity. So ito, merong mass of a dry, stable precipitate. In books class, ang pinaka-common na mga napo-form na precipitate at lumalabas din sa exam ay ang silver chloride and barium sulfate. So, tandaan nyo na. And then, meron na tayong volatilization. Siyempre, kapag may nawala na mass, any loss in mass, yun yung volatiles. It could be water or carbon dioxide. Electro, so merong mass of material deposited on an electrode. Very useful class if you want to analyze metals. And then EGA, of course, this has something to do with thermal. So merong continuous change in mass with temperature or time. Mapansin nyo, naka-highlight ang mass. So any technique class na may kinalaman sa pag-measure ng mass as a signal, this is gravimetry. Okay? So everybody, let's now move on to precipitation. Isang particular method wherein kailangan nating maalala ang steps. Most students na na-meet ko na guys sa on-site, meron daw sila experiment on gravity. So very good kasi you will have meron kang memory, no? Meron kang babalikan. Okay? Dahil kung core memory yan, babalikan mo, oo nga, ito yung ginawa namin. Diba? So very, very relevant para sa'yo. So let's recall the steps. Sample prep. So you dissolve your sample in a suitable solvent at karaniwan, ito ay acid para class ma-bring into solution ang analyte. Followed by precipitation. So we add a precipitating agent to form a precipitate with the analyte. Digestion. Alam to ng lahat. So you allow the precipitate to stand in the mother liquor. And usually class, kinokontrol natin yung conditions. So one condition of the reaction, pwede mo ito kung kailangan mahisen ang digestion. During digestion guys, dito na nagkakaroon ng mga processes tulad ng coagulation, agglomeration, flocculation. So ito yung coming together ng mga nuclei ng precipitate natin. So they become larger. Okay, so kailangan ma-improve ang particle size and purity. Commonly, ito ay nag-range from several minutes to hours. Depende kasi kung ilang oras ang kailangan na digestion para sa sample ninyo. Filtration. Siyempre, na-form ng precipitate, i-filter. O recall from lab reading, ang dami natin kasi discuss na forms ng filtration dito. It could be normal filtration or suction. Okay, vacuum. So to collect your solid analyte. And then class, i-prepare nyo na inyong crucible. Kasi ito class ay mag-undergo later on na ignition. Kung hindi pa pure ha, hindi pa pure ang analyte ninyo. So washing. So this is you prefer class along with filtration to remove yung mga impurities na nag-absorb on your precipitate. And then itutuyuin nyo na yan. Then place in your crucible. And kung ito class ay alam mo may water pa, hindi pa to pure, okay, na precipitate, then you have to remove moisture, convert the precipitate to a stable weighing form. So paano ba mag-ignite? Of course, you place your precipitate inside the crucible at lalagyan mo ito sa muffle furnace. And the temperature will be ranging from 500 to 600 degrees Celsius for around 2 hours. Siyempre, nag-constant weighing ka para sure na lahat ng moisture and any other components na hindi kailangan ay nawala or nag-evaporate na during heating, during ignition. Alright? So mukha siya madali na, ang dali na na-discuss. Mga ganun na kadali. Siyempre class, hindi pa kasama dyan yung performance nyo. Perform mo to, kaya mas matagal talaga siya in reality. Alright? So now, meron tayong picture here na mukhang nag-undergo ng digestion. Alam niyo ba class, yung effective way ng paglalagay na agent in situ, meaning you generate the precipitating agent in the reaction. Okay? Kasi the precipitates formed here, pag technique nyo, they tend to have larger particle size and higher purity compared to those formed by direct addition lang. Tsaka class, another way to control reaction condition aside from temperature is to add your reagent slowly. Okay? Kailangan slowly ha. So kinokontrol mo kasi ang reaction condition para ma-optimize ang formation ng precipitation. So initially, ang solution natin nagiging super saturated. And then, of course, the particles, the small nuclei are now clustering, nag-aggregate na sila, nag-form na sila. Subsequent addition or formation of the reagent can promote further nucleation. Kaso class, kung puro nucleation ng maliliit yung particles. So we need to move on to particle growth. So you need to carefully control your reaction conditions. Okay? Bakit? Mas gusto natin na bigger yung sizes ng particles because they are usually purer. Okay? Mas pure ang mga larger particles. So talking about particles class, ito ang dalawang types ng pwede ma-form na precipitate. Colloidal, very small, cloudy, turbid, gel-like, at maliit nga, difficult to filter, and hence they are more prone to impurities tulad na lang ng surface adsorption. Maliliit nakakapag-offer class ng larger surface area. So kailangan talaga i-digest to purity and particle size. Examples are hydroxides of iron and aluminum. Sa lab namin before class, experiment namin ay iron. So naalala ko yung iron na kulay brown, parang kapano kaninang picture. And then kahit na mag-filter kayo class, para siyang gel, curdy. Alam mo may water pa. So kailangan talaga siyang i-ignite para mawala yung water. Pero swerte kapag ang na-form ng class na precipitate ay crystalline, larger, mabilis mag-settle, not clear na nag-settle ito. Easy to filter kasi nga larger ang size, generally purer, okay, kasi nga lower ang surface area, and then class, ito ay lesser yung chance na merong impurities. So madaling gawin ng paraan para ma-remove ang mga impurities. And then more stable, easier to handle. Examples, yung kanina sinabi natin na common na mga precipitates, silver chloride and barium sulfate. Okay? So class, since alam natin na may tendency to form the impurities, let's talk about co-precipitation. This is the incorporation or association of impurities with your desired precipitate. At marami sila class. We have inclusion, o naka-highlight ko. Foreign ions take place, the ions of your analyte. Occlusion and mechanical entrapment, halos similar. May natatrap inside the growing crystals. Ito class ang pinaka-common, surface adsorption among small particles. Ano may small particles? Sa colloid ba yan? Yes. So very common sa colloidal ang surface adsorption. O ma'am, nagawin na paraan yan? Yes. So ito class yung mechanism nila. So ito yung mga pwedeng mangyari. Okay? And of course, yung corresponding na co-precipitation mechanism. And then effect on precipitate. So as you can see class, sa inclusion, feeling ion sila. Occlusion and entrapment, ayan, naka-trap. Surface adsorption, nasa surface lang. So easily removed by washing. So here are the steps on how to minimize them. Slow precipitation, sabi ko na sa inyo eh. Slow addition lang. And if needed, ulitin mo, mag-dissolve and then precipitate ka until ma-purify mo yung precipitate. And then digestion. Slow precipitation. Then proper settling during digestion. Gentle. O wag mabilis pag nag-filter. Thorough washing. Diba? So kung diba ginagawa naman na yan during the procedure, exactly, ginagawa na to. So you just have to be aware. Kailangan ng aware ka that when you do these steps, you are minimizing the effects class of co-precipitation. Ito na, ating did you know. Mga yan, anong illustration yan? Plus, this illustration is from the book of Harvey. And ito namang mga text here ay galing sa book ni School. Alam niyo ba? Did you know that adsorption is often the major source of contamination in coagulated colloids, pero walang significance in crystalline precipitates? Mitch, does this make sense? Yes. Kasi ang surface area class of crystalline lower, but in colloids, larger ang surface area. So, mas merong chance to form adsorbates. So, pwede ito magawa ng paraan via digestion and of course, thorough washing. Okay, plus itong info ay galing naman sa book ni School. Meron pa tayo, galing pa kay Harvey, adsorption yan. Ano kaya ito? At saka ito. Let's describe here in the first picture. The impurity occupies a lattice site in the precipitate. Alam na, feeling belong. And then here, at the second picture, the impurity is trapped within a precipitate acid forms, pero localized. Okay, ito class ang inclusion, occlusion, surface adsorption. Mga medyo nakaka-confuse. Medyo. Pero itong tatlo class, mahirapan kayo confuse sa sarili dito. Dapat alam niyo agad silang tatlo. Diba? Hard to miss itong definition ng tatlo. Inclusion, occlusion, and surface adsorption. So for sure, hindi nakakalito itong tatlo. ninyo. Plus, meron pa akong nakita na iba pang forms ng co-precipitation. So here, in the first two pictures, mas dinedefine ang difference ng occlusion at ng mechanical entrapment. So, sa mechanical entrapment pala, nasa natatrap lang siya physically, yes. Okay, so this is from school class. And I found another one, mixed crystal formation. Medyo nakakalito siya with inclusion naman. Here, your ions, chemically similar. Okay? Sa inclusion kasi hindi naka-specify kanina kung chemically similar sila. But with mixed crystal formation, nakaforma ng crystals, di ba? So, chemically similar sila, same crystal structure. O, klasa, wag ma-stress sa mga co-precipitation na to. Mga nakikiprecipitate lang yan. So, kailangan lang alam natin yung terms, alam yung general mechanism, and how to minimize them. I also made this paper class summary. Anong nakaka-apektuhan? So, naapektuhan ang colloidal ng mga sumusunod, crystalline din. So, ang crystalline class, kahit na relatively pure to, meron pa ring maliit na chance that they have co-precipitates. Okay? So, ayan guys, very good. Alam na natin ang procedure and pati ang troubleshooting ng co-precipitation. So, now class, we move on to our very short lang na portion on TGA, thermogravimetric analysis. So, ito class, may kinalaman both on mass and temperature. Everybody, let's watch this. Alright, plus nakita nyo, yung malitakan, ang cute, diba? Doon nilagay yung sample, and then nilagay sa oven, and then of course it was under wet heating. So during heating guys, may mga volatiles na nawawala. Okay, as you can see, very sophisticated instrument. Now, this is modern application of gravity, where the mass of a substance is continuously measured as it is heated over time. So class, ito yung thermogram from the book of Harris. Ang sample niya, calcium oxalate monohydrate. So upon heating to 100, syempre, mawawala yung water, and hydrous oxalate na lang siya. So the first step was dehydration, may info ka ngayon. And then, further heating will now remove carbon dioxide naman class. So oxalate is now converted to carbonate. Eventually, carbonate will be converted to oxide. So decomposition na class, yung next na stage. So this is very, very important class if you want to study the stability of your compounds. Ayan pala ang TGA, ina-apply class ang application ng temperature, ng thermal method, at ng gravity. Alright? So please take note of this thermal and gravity method. Okay? So class, meron tayong portion bago tayo mag-compute. Did you know? Gravimetric analysis is one of the most accurate and precise methods of macro-quantitative analysis. Talaga ma'am, kaya sabi nyo, good but good, yes. Kasi class, kung meron ka na namang isa-dalawang sample, mag-gravity ka na. Parang hindi ka na mag-perform ng standardization. O yung remember kanina sa Anakem 2, mag-standardize ka, medyo elaborate na procedure. Pero here's a gravity, meron ka lang balance, labware, oven, furnace, boom, kaya mo na. And most labs naman equipped with this very common instruments. Okay? Take note, calculation ng here's a gravity are based only on atomic or molecular weights. Kaya nga balance yung kailangan mo para malaman yung mass ng sample mo at mass ng residue after ignition. Diba? So madali na class ang gravity. Medyo laborious siya, yes. Medyo tedious gawin yung procedure, but simple, accurate, precise, nuts. Okay? Class, there's an alternative way to dimensional analysis. Some of you may say na, ma'am, mas gusto ko talaga ang dimensional. Mas sigurado ako. Go ahead, there's no problem with me. But let me inform you guys na meron tayong shortcut. The shortcut for dimensional is the use of gravimetric factor. Gravimetric factor is equal to the molar mass of substance. So, yung gusto mong makalculate, X over substance with molar mass of residue. So ito class ay again, shortcut lang, derived lang to from dimensional analysis. So class, pag percent X ang hinahanap mo, divide by mass of sample times 100. Ma'am, lagi bang percent X ang kukunin? Siyempre hindi. Ano lang yan, yun yung pinaka-default. Pero pwede kayong kumuha din, pero ipakompute din sa inyo ang mass of residue, mass of sample, or molar mass. Diba? So transpose lang. Okay, transpose na lang, or kung gusto nyo i-shift solve nyo, it won't affect kung magiging sagot. Pareho lang naman class magiging correct answer. Alright? O solve nyo yung problem sa manual ha. So here, meron kang ore, dissolving acid. So your iron here is now in the form of iron 3, and it was precipitated using ammonia. And then of course, dahil may water pa, let us ignite. So after ignition, you have 0.539 per grams of your iron 3 oxide. Calculate percent iron in the ore. First method, dimensional. So class, ito 1 grams ng residue. And then ito ang kanyang molar mass. Of course, dapat tama formula nyo guys ng Fe2O3. 2 mole ng iron ang meron dyan. And then 1 mole iron, ang molar mass niya, 55.85. O see, madali lang. Pero nga mukha na tumahaba. Oo, kasi may lang naman yung gravimetric factor. As you can see, yung 1111, di naman plus nyo gagawin yun, di ba? Times 1 lang yan. So here, wala na yan, wala na yung mga terms na yan. Pa-clean na lang natin. Ano ba ang nag-matter? Itong 55.85 molar mass ng iron, substance swap, ilan siya? Dalawa sa formula. So ito siya, times 2. And then molar mass class na iron oxide. O, di ba? Yan lang yung factors na nag-matter. Kaya, ang tawag dito, gravimetric factor. I-multiply mo pa rin naman sa mass ng residue over pa rin naman ng gram ng sample times 100. See? Pareho lang. Okay? So class, I hope gets ninyo na madali lang ang gravimetric calculation. So again, pwede i-calculate ang percent X, ang mass ng sample, mass ng residue, or molar mass. So huwag kayo masyadong matakot kung iba ang pinapakompute sa inyo. So class, itong first problem natin, 1 unknown. Ipapa-homework ko sa inyo itong 2 unknowns. Kasi sa board exam, lagi na siyang 1 unknown. Siguro alam naman ng mga examiner na medyo challenging ang mga problems na dalawang unknown. Kaya guys, ito ay pinapa-homework ko sa inyo. After all, galing na dito kay school. At nakita niyo naman, I solved it in a very organized way. For sure, you still remember how to formulate your 2 equations. So gumagamit din ng gravimetric factor. Yes, as you can see, gumamit din tayo dito ng gravimetric factor. Okay? So class, especially 1A, please, aralin nyo yung mga work sample problems na in your manual. Alright? So guys, ito na ang ating list. Ay, wala pala nakalista masyado. Puro nga pala tayo concepts. Isa nga lang pala ang may calculation yung tungkol sa gravimetric factor or pwede kayong mag-dimensional. Okay? So guys, please answer practice test 3. Ito ang mga molar masses na kailangan ninyo. So 1A, ito na ha. And do not forget to submit this via our practice test forms. O, walang mag-excuse ha. Baka ma'am, magagawa ko ng excuse na mahina pa rin ako. Class, hindi na. Dapat gumagaling na kayo. Dapat naka-gain na kayo ng review momentum by this time. Dalawa lang ang problems here. One of them may number talaga. The other one, kailangan yung i-analyze. So you create a working equation, a working formula para ma-solve nyo siya. Ma'am, lahat ba ito nasa board exam dati? Most of them. Okay? Just like what we gave you in online bridging, both practice tests and eval exams, sa basic in-org, eval exam, question set, practice test, ganun here sa ANACAP. Lahat naman class, majority naman nag-appear na. And we're teaching you the basics. Okay? Kayo ay tinitrain, kino-coach namin kayo sa basics. So kailangan talagang gumaling kayong lahat. Alright?